Alrightio, so we've got equations and inequalities for absolute value functions. And so before we get into a few questions, there's just a few rules and properties we need to make sure we know before we actually can do some questions. So the first one is pretty obvious, is that mod x is more than and equal to 0, and that's for all x, for all values of x. So that's number one. Number two is that mod x squared is equal to x squared for all values of x. And we've also got that x over y, and this is familiar to some of the examples we did in a previous video, is equal to mod x over mod y. And then we've got negative x, mod x, is equal to just normal mod x for all x. We've got xy, so x multiplied by y is equal to mod x multiplied by mod y. And the final one is that x minus y inside a modulus is equal to y minus x for all values of x, real values of x and y. And so just looking at a really basic example, just to get an idea of what we'll be doing, is that if we had x, and let's just assume that this equaled to 2, then it would be safe to say that the value of x could be both 2 and negative 2. And this is because if we were to put either of those ones inside the modulus, it would either turn out as negative 2 squared, which we know equals 2, or just normal root 2 squared, which also equals 2. So what we can do is assume that if mod x was to equal a, we can assume that therefore x is equal to plus and minus a. Cool, so let's start off with some easy examples. So to start off here, we've got mod x equals 3, and like we just did before, we can say that therefore x equals plus and minus 3. Pretty straightforward. And what we got here is we got mod x equals negative 5. So I'm not sure if you notice the problem here or not, but we know that any negative within x will end up becoming a positive on the other end. And so it's quite clear here that therefore we have no solution, because it is not possible to get a negative on the other side. Now on to the next question down here. Now this one might trick you a little bit, because you might go, oh, you know what, we've got a 5 in there, we can do something here, and we don't have to worry about that negative there, we're completely fine. But unfortunately, even questions like this, there is, I'll just do NS, there is no solution for that either, because we can, no matter what, we cannot have a negative here. Now on to the next question. This is one we can actually do. So what we can do is first take the values outside the modulus. So we've got 2 minus 5x, and this will equal plus and minus 12. And then what we can do is we can separate this into 2 columns, and I'm going to try and write as small as I can. So we've got number 1, the first column, where 2 minus 5x equals normal 12, and in this column where 2 minus 5x equals negative 12. So what we can do is, I reckon I'll move this value over there in both examples, and in turn move this on this side, because I don't really want the x to be negative, so let's evaluate for that for both of them. So we'll have negative 10 equals 5x, and on this side we've got 14 equals 5x, and then we can evaluate this one more, and we can say therefore x equals negative 10 over 5, therefore x equals negative 2, and then this one we've got x equals 14 over 5, which can't be evaluated any further, So for this one, our final answers are, well, I'll write that down here. I'll say, therefore, and we'll try and draw a line there, x equals -2 or 14 over 5. We can do a better 5 than that, like that. On to the next one. So we've got a slightly more complicated one this time. So we've got a fraction inside a modulus, but it shouldn't be too hard to evaluate. So what we'll do is I'll represent it saying that, therefore, and we'll get rid of the modulus. We'll say 2x minus 1 over x plus 1 equals plus and minus 5. And then we're going to split this into two parts. So I'll split it by writing an or in the middle. And so we'll have one part where 2x minus 1 over x plus 1 equals 5. And another part where 2x minus 1 over x plus 1 equals -5. And so we'll start by evaluating the left column. So this, what we'll do is we'll put this in the bracket basically and multiply it with that one. And so we'll get 2x minus 1 equals 5x plus 1. Therefore 2x minus 1 equals 5x plus 5, having expanded the bracket. And then what we can do is we can move a few things around. So it might start to look a little bit tricky, but hopefully it won't be too bad. But I'm going to move that there, so we can get the x on the left, and then move the 1 over there. And so we'll get, therefore, -3x equals 6. And then moving both the negative and the 3 over, we can say that, therefore, x equals 6 over -3. So therefore x equals -2. Now on to the other side. So we can say, do a similar thing here. Therefore 2x minus 1 equals -5. And then in brackets x plus 1, which we can evaluate as 2x minus 1 equals -5x minus 5. And then so that will be moving things around again. This one will be a little bit easier. But we'll have, therefore, 7x will equal -4. So therefore x equals -4 over 7. So now we've got two questions with absolute functions on both ends of the equation. And so we're going to follow a slightly different process this time, but it's pretty similar. So with the first one, we can evaluate this to say, therefore, and we'll get rid of both the moduluses at once. So therefore x plus 1 equals plus and minus, and we'll create some brackets, 2 minus x. And then so we can evaluate that in two parts again. One where x plus 1 just equals 2 minus x. And then the other where x plus 1 equals -2 plus x. And so we can rearrange these. So this one will be 2x equals 1. And this one will be undefined, as these two x's will cancel each other out. So then we can just evaluate the other one completely. Just say, therefore, x equals 1 over 2. And then we can do similar for the next one. So we'll say, therefore, 3x plus 2 equals plus and minus 2 minus x. And so we can evaluate that into two parts again, like with the or here. So we've got one where 3x plus 2 just equals, and we'll evaluate it right away. So we've got 4 minus 2x, and then another one where 3x plus 2 equals -4 plus 2x, like that. And so let's just evaluate the left one first. So we'll just move some parts around. So we'll have 5x equals 2. So therefore x will equal 5, or 2 actually, over 5. And then this one where we've got x equals -6 right away. And so then these two are our final answer for that one. So let's have a look at another example where we've got to find the value of x both graphically and algebraically. So if we look at this graph, we can see that both these lines intersect at the point. We can write it as 1 and 3, like that. And so simply from the graph, we can infer that the value of x, which is at this point 1 and 3, right, is, and this is quite obvious, is x equals 1. But what if we were to do this algebraically and actually evaluate it? So what we would do is we would have, obviously, let's rewrite the equation of x plus 2, like mod x plus 2 equals 2x plus 1, which obviously we can evaluate that to become 2x plus 1 equals, and then plus and minus in the brackets, x plus 2, like that. And then therefore, and then obviously we're going to have two sections this time, so I'll write or here, and we can say 2x plus 1 equals just positive x plus 2, or 2x plus 1 equals negative x minus 2, and then evaluate that. So x equals 1, or, and then when we evaluate this next one, we'll have 3x equals -3, therefore x equals -1. So then that gives us two options of, therefore x equals 1 or -1. And we know that in the graphic example we got 1, and that was one of the examples when we did it algebraically. Here we've got two new questions. So we've got mod x is less than 4, and then we've also got mod 3x minus 2 is more than and equal to mod 2x plus 3. And so we've got the graphs for both of them here, but let's just have a look at the first one. So we can pretty clearly see that obviously this purple blue looking line is the y equals mod x, and then the pink looking line is y equals 4. And so we can clearly see we've got two main points here, and they both meet at -4 and normal +4. And so what we can infer from this graph is that they intersect at x equals -4 and 4. So if we were, for example, to evaluate this function here, it would become x is less than plus and minus 4, which aligns with those intersection points. So what we can do now is say, knowing that mod x has to be less than 4, we know that the only section we need to look at is this section here. We can forget about these points here because it needs to be less than 4. So what we can do is we know that only occurs when y, because we've got the 4 point, is less than 4. So then we can say that the range for x just belongs between these points. And so we can say, therefore, we've got -4 is less than x, and x is less than +4. And then we can say, therefore, x belongs to, and then -4 and 4, like that. And then for our next one, we've obviously got these 2 points. We've got x is -1 over 5, and then x is 5 here. So I can just write those in and say, instead of intersect that, I'll just write, so x equals -1 over 5, and this is the intersection points, and +5. But what we do know is we're only looking for the mod 3x minus 2 function where it is actually more than and equal to the mod 2x plus 3. So what we're doing is we're only looking for the points where this is going up and up here, because those are the only points where it's actually more than, let me just get rid of that, more than that point there. And so what we can say then is that, and I might just put it down here, we'll say therefore x is more than and equal to -1 over 5, putting that point in there, and x is more than and equal to 5. And this was actually less than and equal to, sorry. And then so what we can do is say, therefore, x belongs to, we're going to have 2 points here, is we're going to have negative infinity. And the reason that is it goes this way. And so x is going to continue negative for infinity distance. And then that's from this point of negative 1/5. And then we'll do the union symbol. And actually we'll make this one more of a straight bracket there, same with this one. And then this one will be 5, and then positive infinity, because this continues up that way for infinity distance. And then we can close that bracket, and those ones completed.